Good day and welcome to Chemistry Tutorials with Tutor Emmanuel Oyedun. And today we are going to be solving this redox reaction. Now this is an example of a reduction oxidation procedure reaction, and how do we balance this kind of reaction. So follow me carefully, because in redox reaction you must get to the point where both the charges are balanced and the number of atoms are what? Balanced. And we are going to be using the half reaction method in balancing this redox reaction. Okay, so we are going to write out the equation into their respective processes. So I have MnO4 direct to Mn2 plus C2O4 2 minus to give CO2. Okay? So I've splitted the reaction. So how do I identify which one is oxidation, which one is reduction? Now, anytime there's a reduction in the oxidation number, of course the oxidation number of the species here is +7, here will be +3, here is +2, and here is +4. Okay, how do I get +7? Very simple. I will say Mn plus the oxidation state of oxygen is -2. I have 4 molecules of oxygen is equals to -1, the charge on it. By the time I say Mn plus -8 is equals to -1. Mn is equals to -1. This one will have become, this one will be Mn minus 8 is equals to -1. Mn is equals to -1 plus 8. That will give me +7. If I do the same thing for all other species, I will get all these values that I've mentioned here. So from +7 to +2, that is reducing, and that process is definitely reduction. And from +3 to +4, there's an increase, and that process is known as oxidation. So I will look at the oxidized and reduced atoms. Are they balanced? I have one manganese here, one manganese here. That makes it balanced. I have 2 carbon here, but 1 carbon here. So all I need to do is to balance the carbon atoms. So having done that, I will balance other atoms present, adding water where it is necessary. So for this reaction here, there's oxygen here and there's no oxygen here. So I'm going to add hydrogen to this side and add water to this side.